I
Okay,
have posted this, Sonam. Yeah.
sure. Thank you, Prithvi. This is the course EDA Exploratory Data Analysis. These are all videos in these course. If you check, it has all the videos. So topic wise, you can click on the videos and go through it. So data and code files you'll find here on this page, data and codes used in this course. So first one is the code and data set which are used for the demo purposes. Exercises, you have to click this one, and for the last one, the capstone project, you can click here. In between also, there might be rare cases. At times, you'll find some files in between of the course as well. In case you're not able to download any of the file, do let the team know. We'll help you out in downloading these files. Now let us go and try to understand what is exploratory data analysis. See, EDA is about exploring your data, looking into the details of your data, checking how your data looks like. If you have any missing values in the data, we'll find that. If you have a lot of repetitions in the data, if some features are not required, we'll see if there's any feature which is not required, or if we need to normalize any feature, if it is not in a proper shape, proper format, we'll do that. All those things we'll do in the exploratory data analysis. So it's a step-by-step procedure. We first of all will learn how to collect the data, how to organize data, how to import data from various sources. So here we'll see first of all what is data, and then we'll go on and check out how to import that data into the Python environment. Once we are ready with the data, so these are different ways how you can import data. If you have a CSV file, how to import, from Excel file, how to import, from databases also how to import has been discussed here. I'll show you one example here. Multiple databases have been discussed, how to import from MS Access database, Oracle, or how to work on XML files. If you have XML files, from that, how do you read those XML files in the Python environment? We'll see a small example here. Once you have imported the files, imported the data, or you have brought the data into the Python environment, then we do the pre-processing step. In pre-processing, we'll check if the data is proper. If there are any inconsistencies in the data, we'll remove those inconsistencies. We'll see if there are some negative entries for the columns for which it should not have been there. If there are lots of none values, missing values in the data, that we'll see and try to omit those missing values. We'll see how to delete data based on some condition. Maybe some columns I do not want in my data, or some rows I'm not looking for in my data. How to delete that, or how to delete the null rows. If a row has too many null, if my data, any column has too many nulls. Maybe let's say I have 100 records in my Excel files. Out of that 100 records in a particular column, 40% of the records have null values. That will change the meaning of the outcome which I want to retrieve from my data set. So I'm not interested in all those null values. Maybe let's replace them with something or delete those values. That decision we'll see how you can work upon that. So we'll see how to delete the data values, then how to impute data. Impute data means replace it with something. Those null values, see, the easiest way is you delete all the rows which contains null values. That is the easiest way. But what if I have 100 rows? Out of the 100 rows, 40 will get deleted. That's too much. I don't want that. But what about the other attributes of those 40 rows? They might be of some importance to me. So I can't always take that hardcore step of deleting data. So sometimes what we do is we replace it with some other data values. For example, if I talk about let's say height of a student in a class, 40 places height was missing, at 60 places height was there. I want to find average height of students in the class. So I don't want to omit those 40 students, escape those 40 students. I want to include them. My average should be out of 100, not out of 60. In that case, what I can do is maybe replace their heights by some constant value, constant height, or any, we can find mean height of the rest of the 62 students, and then allocate it to all the missing values, or any other statistic like median, mode, most frequently found value. Anything can be replaced. That comes under imputing. We'll see how to do that. How to impute data with a constant value, with a mean value, most frequent value, median value. We'll see all these examples. We'll learn how to merge multiple data frames. So we talked about data frames in Pandas library. So now we'll see how can we, if we have two data frames, how do we merge it? How do we split them, subsetting a data frame, find a subset of the data frame, how to order a data frame on a particular column, how to group data, we'll see. So all this we'll see under the pre-processing step. Once our data, once we are done with all this pre-processing, which helps us in exploring the data. Further, we'll go on and try to find the relationships between data. Maybe there are some variables in my data where one variable is needed for some dependent variable. Like if I want to answer what's the price of the car, so maybe the price of my car will depend on the mileage, the number of kilometers driven. So is there a relationship between the number of kilometers driven and the price of a car? How do we check that? Are they related to each other? Is there a linear dependency between those two variables? Are they not dependent? So what are the variables on which price is depending? All that relationship, all that exploration has to be done, that understanding has to be done, that we'll do in the next phase, which is exploring, and then we'll summarize. Once, see, exploring comes with visualization also. Data visualization you have done in the last class. Before that also you have seen how to visualize data in Python for data science, because we are doing data analysis. Once you analyze the data, you have to present it somehow. And that's why visualization is the core part, you can say. The final outcome has to be visualization in terms of visualizing your data. So here we'll revisit some of the ways in which you can visualize the findings which you have discovered in the previous stages. So how do you visualize those things? So with one or two example like bar chart, box plot, histogram. So we'll see all this. So let's get started. I hope you can see my notebook. Okay, thank you for responding. So you can do this. You can go through the course. If you go through the course, I think you have this notebook also you can download from the demo section. So I also did the same and did some changes on my own. This is the same notebook, so you can download it. Maybe at times when you download or you write some code which is there in these courses might not be working, because these libraries which we import from time to time, they keep on deprecating these libraries. So if something is not working, then you can Google it out and find an option for it, because that part, that functionality, that library or that module might have got deprecated. That's the only thing which might have happened, which I faced here. There was a function distplot used here, which has been deprecated. So in place of that, I have used histplot for plotting histograms. So those small changes you can figure out yourself. Now, this we have to do to ignore the warnings which keeps on coming on my notebook. Otherwise, we'll import all these libraries, NumPy, Pandas, Matplotlib.pyplot for plotting. You are familiar with all these now. In Python for data science course, we have talked about all these libraries. So NumPy for numerical calculations, Pandas for data frame, Matplotlib for plotting, Seaborn also. See, Pandas, Matplotlib, and Seaborn, all of them have some visualization tools. So in Python for data science course, we have seen how to plot data using Pandas. Data visualization, we have seen how to do it with Matplotlib. Now here in this course, we'll see how to use SNS, Seaborn for plotting. So it also offers some modules for plotting those basic plots. Now let's see how do we import data into our environment. How do you recognize data? I hope you know all that theory about data, how many types of data are there. Let's go to this first of all and see. When you download, here in this course, we'll be talking about uh, a restaurant data. So there are certain files which you will see. Let me take you to the classifying the data. Okay, let me just open it once. Okay, So, see, data can be classified into three. Data can be a structured data, like structured data will be stored in the form of a proper file format will be there, like how you store data in your Excel files, CSV files, JSON file formats. They are structured data. But most of the data on internet is in the form of unstructured data or semi-structured data. So the data which is in the form of XML files, HTML files, emails, it's classified as semi-structured data. Apart from that, whatever data you see in the form of image, videos, that all comes under unstructured. So here we have this example where you will see certain files. Okay, so here let me go back. So TDA master exploratory data analysis. These are the files. I hope you can see my screen. Once you download the data folder, you will be seeing all these files. So I'm showing you all these files once because we'll be using all these files. You should know what's the structure of these files. Just go through all these files first of all to understand what is there. So this is consumer survey file which contains all this. So it has there's a survey, gender, and you can have a look.
Yeah, it's Sonam. I think the screen is hanged. Can you reshare it?
Okay, you cannot see the screen. Maybe that is another window, no? That's why. Okay, I'll reshare it. Wait.
Because we are not able to see the files that you were mentioning.
Got the point. Wait. Okay, I'm sharing my screen for now. I hope you should be able to see.
Yeah.
Are you able to see now?
Yeah, we
Prithvi,
can
is it
see
visible?
Excel sheet. Yes.
Okay. So I have shared my whole screen now. We have these files. You will not find this restaurant details file, but I have created this. I'll tell you how to create this restaurant details file from the data available. We are talking about a restaurant whose place ID is there, name of the restaurant, address of the restaurant, state, country, zip, and all these details are there. We'll be working on average dine-in per month column. So average, how many people are coming to this restaurant per month is what is stored in this. So similarly, you can check out the other files as well. Consumer survey file is this. So survey details, survey data. So it talks about here, this FRBPM column we'll be working on. This talks about restaurant visits per month. How many people are visiting the restaurant per month? This column we'll be interested in, and let's check dining preferences of the people. So this file talks about in the year how many people opted for dine-in, how many opted for home delivery, year-wise. Feedback is a text document. So see, we have this text file. Text file is unstructured file. This is an example of unstructured file. So,
Sonam, sorry to interrupt here.
Hmm.
I don't think we came across types of data, that is the unstructured and the semi-structured and the structured data. Though we have a small idea of what it is, if you can give a little examples for each.
Yeah, I'll do that. See, this is unstructured. Structured will be all your Excel files. If I say, if I go to this restaurant details file, which I've shown you, this is structured file. Or CSV files are structured data. Your JSON files, which is not there here, is also a structured data. But I have an XML file here. See, this is reviews. This is an XML file where in an XML file you have tags like I have restaurant ID for this particular restaurant, name, zip code, and all. What are the special features of the restaurant? Then I have reviews. Under review, I have different people giving reviews for the same restaurant. This XML file talks about only one restaurant. Details of the restaurant, special features is a sub list. And then I have reviews from multiple people for this restaurant. This is an example of semi-structured file.
I guess that MongoDB also comes under the semi-structured category.
MongoDB files, yes, MongoDBs are not properly structured. They are not a relational database. They are database files. You can call them as structured, semi-structured because they are not in the proper RDBMS format. Restaurant cuisine has to So this file talks about which place offers what type of cuisine. This Excel file. So go through all the files because you should have an understanding of what is there in each file. Let's do one thing. We'll import all these files in the Python environment. There I'll show you what's the data of these files now. Okay, so let's start with CSV files. For importing CSV files, you have to use read_CSV. And you have to provide the whole path as I've given here. See, I've just copied the path of that. Right click, copy path, and provide the complete path here. And before this, don't forget to put R, which states that it is a raw string. So what happens, all these colons, backslashes, which you have used here will be treated as it is once you write this R. So this R stands for raw string. Okay, so once you have read this file using read_CSV, a data frame is prepared for you, which is stored under user rating, and .head method can be used to print first 5 rows of your file. You want me to show how to copy the complete path? You go to the file, right click and say copy path, copy as path. Is it coming in your system? If not, you can go to properties and from there you can, it's not coming. Then you go to properties and then copy paste the path. Right click on the file, go to properties, properties will show you the path. But there you have to make a little change. Properties will give you a path till data. And then file name you have to add yourself. Okay, user rating file contains data which user has given what rating for a particular place. So ratings, we have 2 categories of rating. So user 77 has given food rating as 2 and service rating also separately has been given in this file. So this is how you get data, fetch data from CSV file. Let's see how to read data from Excel files. Instead of read CSV, read_CSV. You can invoke read_Excel function from the same pandas library. So PD, we have already done import pandas as PD, and now you read this Excel file. Provide the path of your Excel file and print. Head will give you first 5 records. If you want first 10, first 15, first 12, you can supply that number here. Okay, if you're interested in a particular number, then you can do this. Or if you're interested in checking last 5, last 12, then you can give your tail, survey.tail. Instead of head, you can use tail here. Which file? Those files I have saved anywhere in your system. It's there on my desktop. I've created a folder, subfolder. See, this is my folder. Desktop, AI, data science, data analysis, so and so. Then I have this file. So it can be anywhere. You just have to get the path and use it. Okay, so this is my Excel file. Let me run it again. These are the first 12 records. So my consumer survey file has the survey details. Male was a smoker, false, drink level, preferences, dress preferences, and all. So this is a survey file. Another file, let's see what's there inside this restaurant parking. You will get this file, Excel file in that same thing. This file contains data, whether or what type of parking does this particular place offers. So place ID 111 has a public parking like that. Let's check first in records. So public, none, parking is there, or we have valet parking. See, different type of data is there. It's not streamlined. It's not that we have certain categories, public, private, yes or no, valet parking there, not there. So we have different types here. That's why data cleaning is required. So many nuns are there. See, in this, so many places do not have data. Like now, if I ask a question, how many, find the percentage of places which have parking. So how many yes I'll get? Hardly some yes I'll get from this data, but it doesn't mean that other places do not offer parking. They offer parking, but something else is written there. Valet parking is written, public is written. So these things will be ignored. So to do that analysis, we have to modify it. We have to normalize this. Either we pick up yes or no data in the form of yes or no, or public or private, or some categories we have to decide and then transform this data. Then only we can ask that particular question. Dining preferences, year-wise, how many people have opted for dining and home delivery options? You will find in dining preferences. So this is a kind of a database, you can say, which contains all these files. Restaurant cuisine, place corresponding to the place which cuisine it offers, you'll find in this. Still, we are using the Excel, read Excel function only. So to read the structured data, you can use CSV. You will be going for CSV files or Excel files. So read CSV or read Excel, you can use to get those files. Now let's see how to fetch data from databases. So for databases, you have to get a driver or the adapter we have to use. So Python offers some libraries, these adapter libraries, like here for MS Access, we have used PYODBC. PYODBC we have used. You can import this, and there's a particular format which you have to follow to import or to open a connection to these adapters. So what we can do is provide a path, first of all, path where my file is stored. So I have a file restaurantcuisine.accountdb. When you download that folder, you will get this file, restaurantcuisine.accdb. So this accdb stands for MS Access database file named as restaurant cuisine. So that file is stored somewhere. That path you have to provide it, this dbq, and then Microsoft Access driver you will be using. So that driver you have to supply here. So this connection string we have to form and then use PyODBC adapter to connect to this file, this particular file, which is stored on our system. Once you get a connection string, then we have to open a cursor. Cursor is a workplace or working environment where you will fetch the data from the file. Once you have got that workplace working environment, then you go for the so currently we are using MS Access. We are seeing how to fetch data from Access. I do not have Oracle on my system. I will show you MS Access and SQLite. Oracle, if you have on your system, you can try yourself. So this is fetching data from MS Access. So for every row which is there in this cursor, we can print that row. After printing your details, you have to close that connection, which you have started here. These 2-3 lines we have to remember. How to form the connection string, then dot connect function to connect to this connection string which you have established. Then we have to open a cursor, and then we give the state query. We want all the data from the cuisine file. So it's printing the details of the file. What, this is big actually. It was quite big. SQLite 3 is a very light database which you can install very easily, and we can import this adapter. So if before doing this, import SQLite 3 or PyoDBC, what you have to do is you have to do this pip install. Do not forget to put this line also. You go to the terminal window of the Jupyter, and then you have to do this. You want me to show you how to do this? I have already done it. I will not repeat it, but I'll show you how you can do this. So you have to go to this terminal window in the Jupyter notebook. Are you able to see my terminal window? Yes. Okay. So here you have to find how you do. For my system, I have to write like this, pip install. So if I want to go for SQLite, then DB SQLite or PyoDBC, here you have to write this. This line might be different for you, pym. Pip install will be same, pip install, PyoDBC will be same, but this depends on a Python version or sometimes the installation. So how you open your Jupyter notebook, that time you might be using certain string here. Now that same string you have to use here before pip install. Yeah, you can use anything, or if you don't want to do all this, go to your Colab also you can use. So before importing any of these libraries, install it first. And then you can import SQLite 3, third version of SQLite. Steps will be same. We'll have to open the connection to a DB. And then we have to get a cursor, work area, workplace where our details can be stored. I am dropping this file first because I was using it repeatedly. So initially let me drop it because already it might be there on my system. I am dropping it. If this comes, it means correctly it has been dropped. So I have dropped restaurant details table from my system, and then let's try to create it again and see. So you can create a table also from here. It's not just about reading data like we did in the case of MS Access. We didn't create any file. It was already created. We were reading data. Here we are seeing how you can create the file from scratch here. So in the execute, instead of, you can give any type of query command here. So see, we have given drop here, and you can create the table here if you know SQL, how to create tables in Oracle or SQL. This is the same syntax, nothing different here, how we create a table. So create this table, restaurant details, which has place ID, address, country, and then last average dine-in per month we have here. The data type, number, varchar to 10, that data type also you can provide along with the size. Next, what we have to do, let me execute it. So if this comes, it means executed properly. Now let us insert some values in the table. So here we have to go for insert statements, insert into the table name and the values as you do in SQL. Oracle or MySQL, the syntax is same. So these are so many records which we have, which we'll put into the database. Let's see, execute it and check. Okay, so it's not printing anything because I have not issued a command select. I have just created a table, inserted a table, or dropped a table till now. Okay, I have made some changes to this file, restaurant details, which will be required. At some places, I have inserted nulls in the last column. What I'll do is, these two I'm sharing on the chat window. At some places, I inserted nulls here. Not sure whether this will go. Okay, this chat window will not allow me to paste such a huge amount of data. What you can do is, when you will download that folder, in that folder you'll see RD insert script. There's a file named as RD insert script. So it contains these two things, create command and your insertion statements are there. Just see if you have some null values in the last column. If you do not have null values in the last column, then insert some null values that you can do. Okay, we'll go ahead. I have inserted data into my table restaurant details. Now open the connection again and create a cursor again to fetch the details from the restaurant details so that I can make a data frame here. Reading the file. We have created a file so far. Now we are reading the data from this file and we'll be working on it. So same thing, connect to the database, cursor, and instead of execute, this time we are using the read SQL command to execute this SQL statement. Restaurant dot head. So this is my file which we have created just now. Place ID, name, address. So here we are learning how to get data from these types of files, structured files, CSV files, Excel files, databases. XML is a semi-structured file. So semi-structured file, let's see how do we work on the semi-structured files. How to clean data, we'll see later. How to process that data, work on it, we'll see a little later. So this is my XML file where I have reviews, which I showed you. So one particular restaurant and the attributes of that restaurant along with the special features and reviews by few people. 3-4 people have given reviews for that particular restaurant. So it holds data about that. Now we have, if you know about XML files, it has tags and it has a root element as well. So you can get that root element by invoking this method get root. So this is a fixed syntax which we have to use. From elementary class, we can use parse function to access the XML files, and to get the root, you can use this get root function, displaying the tag of the this file is restaurant and ID. The first ID was this one. So for this particular ID, there are reviews in that file, reviews.xml. Now my root points to the root element, root tag of the XML file. I can use it. So for every element in the root, I can print the element which is there in the root. Let me form a dictionary. You know, in XML files, I have a tag. Corresponding to the tag, we have a value. Looks like a dictionary in Python. So we can, what we'll do here is we'll fetch data from those XML files and put it into the dictionary format. Create an empty dictionary first, which is restaurant dict. So this is empty dictionary. We'll read each and every element in the XML file and put it into the dictionary element is what we will do here. So for every element in the root, add it to the dictionary. Add the tag of the element, put a colon, and then put the text of the element. So if you remember, in after restaurant ID, we had certain attributes of it: name of the restaurant, zip code, cuisines, price level, hours, payment. Now, if you remember, I showed you this file, and there was some sub lists also. Special features had a list. 3-4 special features were there. Similarly, reviews were 3-4. There was a sub list and a sub list inside reviews. 3-4 people have given reviews, and details about the person who has given reviews also was there. So there were 3 levels inside this, 2 levels here. That has not been printed if you do only this. Now, how to access those sub elements and sub elements, we'll see in the next section. So if it is a normal element, you can insert it into the dictionary just like that. Insert it into the dictionary. If this element lies inside this element, so if it is a sub element, then what we can do is create a list and append that list here to be displayed. Special features. We want the complete XML file to be displayed. We want all the reviews along with their sub details to be printed. So for that, what we are doing is for every tag, we are displaying the tag as well as the text and checking if this particular element contains a sub element. If it contains a sub element, we are preparing a list of the elements which are there and then appending that list to the this section. Similarly, if it has a subsection, we can check if it has a sub element and then prepare a separate dictionary for it, append that dictionary or append that list to the original one, and we can display it. You have to go through this code actually to understand what is happening here. I've just told you the gist. Here we are checking for sub elements, that is special features it will be able to check. But reviews had 3 levels of data, 3 levels of tags it had. So for creating the list up to 3 levels, you have to do this. So you go through the code one by one, you will understand. Not that difficult. Now you can see the difference. Earlier, we were not getting this list. So this sub list we prepared here, special features list. And then reviews, we had review number 1. Then we had so many reviews here. So all the reviews are getting printed, whatever reviews are there. So in the reviews, now you see, we had review ID, review. This is the review ID. Then we have second review ID here. So this is my sub element. And if I talk about what is there inside this, user type, title, username, again, one level of element is there inside this. So so a little Python knowledge is required to print all this. If you want to print it in a neater way, so this code shows you how to do it, separated by some lines, each review separately, because here it was not readable. It's just making it align and making it readable, only the review part. So after reviews, it will give you a line and show it neatly so that every review gets separated. To read data from unstructured files or text files, basically, we have read underscore table. This, don't get confused. Table is not for reading data from your RDBMS table or your Excel table. It is for a text file. Read underscore table will help you read data from your text files. Like feedback was there, I showed you a text file. So that file, when you read it, it contains all the reviews. So line by line, it displays all the reviews and automatically indexes are added here. This 0, 1, 2, 3, 4 was not there in my file. It is added here when I make it a data frame. So this becomes a data frame with indexes starting from 0. So these are the first 5 reviews. Let's see now how can we clean the data? How do we process the data? Let's check for inconsistencies in the data file. Okay, this part is not there in the course. What was happening, I think when I downloaded the files, restaurant details CSV file was not there. Again and again, you will be needing this file here because we'll be using it for cleaning purpose. I explicitly converted this database file to the CSV file using .to CSV. 2 underscore CSV is used to convert a data frame into a CSV file. So I have to give it the data frame. This is my data frame, which I prepared earlier, if you remember, from the insert commands which I have supplied, that restaurant details. So that restaurant details data frame, I'm converting it here and saving it to a CSV file. So again, a path has to be specified here. And then same file I will be using for processing the data. You see if you already have it, or otherwise you can use it and share this code. You can give the path where you want to save your file. And that same path you have to use here in the next line. So my file contains all these details. Now let me check the different values, the frequency of the rows. So this is the restaurant details file. You can see what are the state values in this. We have Morelos, we have SLP. So SLP stands for San Luis Potosi, but there are different ways in which the same data is written. You can see if I print more rows here, maybe you will be able to understand. Okay, just look at the state column. I have S.L.T here. Tamaulipas I have with starting with small t, then capital T. Now see, this is one way. This is second way. This is third way in which SLP is there, this state. There might be other ways as well, but all of them means the same state. I want to count how many records are there for each state. If I do this count on state, then I'll get this variation here. How many different types of states are there and how many rows are there for each state. If I want to know this frequency, you can make use of this value counts function. So it counts the number of values for SLP. So 50 times SLP, capital SLP has been used. Now 2 times small SLP has been used, 2 times this variation of SLP has been used, and one time this variation of SLP has been used. But all of them mean same. You will not be able to get proper details. If I want to know how many people have given reviews from SLP, how many people from SLP visit the restaurant, will this give me a correct picture? No. So this data has to be cleaned. What we have to do is now a little Python we have to use here to transform this data. Transform or remove inconsistencies in this data. What we'll do is wherever it is SLP, SLP, this SLP or this SLP, what we'll do, we'll choose one value. We'll replace all these data by one value. Similarly, wherever it is Tamaulipas or Tamaulipas, we'll replace it with one name. Same for Morelos and Mexico also. So we will transform these values. Let's see how. So look at the next cell now. For every, for all the rows in my restaurant details table in the state column, wherever it is these two, replace it with capital T Tamaulipas is what we are doing. So what this line will do, see here, we don't have to iterate. Explicitly, we do not write how we do it in Java. Here you can give it in one line. So all my if condition for loop, we are doing it in one line. For every value of these two, replace it with Tamaulipas. Now you have to note here, we have left a space here because in the data set, a space is there. The space might be there. If it is there, leave a space before and after. If it is not there, you check your data, do not leave it here. Similarly, these two will be replaced by Morelos starting with capital M. All the variations of SLP, so many variations are there. See, if any of these variations are there, that you can replace it with one particular state value. Similarly, Mexico can be replaced by this Mexico. So this all we have to do manually because all these rules we have to identify all by ourselves and do it. I hope this is easy to understand what we are doing. Then you go and print. And now check the values. See, my data looks consistent now. It is just that I have not taken care of my nuns or empty. If state cell is empty, see it stands for empty. There are 18 rows for which state value is missing. Or there might have been NaN value or none value here. Those also we'll see how to treat or how to consider those values. Let's take a count. Now this is my current state because after modification, after updating my state column, it tells me this. So at least it's just the name of the state. See, instead of this San Luis Potosi, SLP was written in different ways. While entering, data entry operator might do these things. There might be inconsistencies while storing data. It's not that state is wrong. It's just that different people have different ways of writing. Either you put some checks on data entry, or what if you do not have those checks in place? Then we have to clean data before giving it to the algorithms. You have read about that machine learning process. Before that, we have to do some feature engineering and feature cleaning. That is what we are doing here. Blanks, we'll see how to deal with blanks. Either see what we do is remove all these 18 rows, delete. Wherever it is null, delete all those rows. Or what you can do is choose for a constant value, constant state here. Decide, let's say it is Mexico, wherever it is space, default, like this default column, we can create in databases. It's just like that. Set up a default value here, or maybe you can go and check which is the most frequently occurring state in all my rows. That we can replace here. So this algorithm can be anything. Okay, this talks about the data size as well, shape of the data, 130 rows and 13 columns. We have, again, when you do value counts, we have already done it. It's showing us this. You can do the same for country as well. Country dot value counts gives us this. So Mexico is written in different ways. We have country question mark as country. We have NA in place of country. So wherever it is Mexico, Mexico, replace it with Mexico. You can try this, then take a count. So all the at least Mexicos will be combined here till now. So we have just now seen how to replace these values, how to remove the inconsistencies, the varieties, how to deal with the varieties of data. Now let's see. I hope it has. Okay, this is giving me 0. We are checking frequency of restaurant visits per month. And at how many places we have a value less than 0 here. I need original data. Actually, all my data is modified now. I need to download the fresh data from the course and then use it to get the right values. Let me do it. Give me 2-3 minutes. I'll download the original data sets. Wait a while. We are not making unstructured data to structured. We are just cleaning the data and so that it can fulfill our requirement. Okay, let's get back Fresh file also doesn't have any negative values. It's just to check how many, if we have any negative entries here in this column, if by mistake any negative entries have seeped in. So what we are doing here, we are using this LOC, LOC. You remember this LOC? Have we used it in the last class? LOC, ILOC. Yes. So LOC function is used to locate a value. ILOC is also used for that. LOC function has one benefit that you can give any Boolean value also here. Boolean attribute also it takes. So for locating here, see before comma, we are specifying something about the rows. And after hello everyone, am I audible now? Okay, thank you. Yes, I think there was some glitch. I could see to all your messages, but you people were not able to hear me. Anyways, let us go back. Okay, so again, once again, let me tell you what we are doing in this locate function. This locate function LOC function takes a Boolean value also. So we are putting a condition, a Boolean, it will return a Boolean value for every row. It will check if the value of FRBPM from this consumer survey is less than 0. So only for those rows where it is true, get all the columns is what we are locating here. Find all such rows. How many such rows are there where the value of FRBPM is less than 0? That means we have negative values. Similarly for AERPM column, we are checking. So in our actual data, we have no such values here. Let's see, let's take a temporary data and see what do we do with the negative values? Is my voice still cracking or okay now?
It's clear, Sonam.
Okay, thank you, thank you. All right, so let's take a sample data where we have negative values also. So in our data set, negative entries are not there. So we have taken a dummy data set here. So let's take, this is the data, check for the negative values here. You can use the same function to check. Now here, what we are doing is, we are replacing all the negative values in my data set with 0. As we replaced here, replace the countries, replace the state, same way we can replace all the negative values. If my I value is 0, replace it with 0, otherwise let I only be there. So replace all your negative values with 0. But before this, you need to know, you need to explore it. That's what you can do here. Keep a check on your data. If you have negative entries, then you can go for replacement. Because if you find a mean like this, then it will give you, your mean value will decrease a lot. But when you take a 0 here in place of these negative values, then maybe a correct picture of mean you can get. So np.mean can be used directly to get the mean, median, mode, all those statistics. Or what you can do is, instead of replacing, if you want to reduce your data set, just remove those values. So this time we will not give the else part. We will say, if my I value is greater than 0, then only print it. Then take a mean of it and see. This time a mean will change because some values have been removed. Two values are not there. So the mean will change. Now let's say these are marks of a student in some subject. Check the mean marks if we do like this, or we are checking the mean marks like this. In your data sets, you will frequently see values with NONE. That NONE is a string which has been written, or otherwise you will find values with, there's a thing called NaN, not a number. So numbers you will see can be replaced by NaN. Instead of having null NA, you will sometimes see np.nan. So this np.nan, NaN comes when maybe, let's say, you are trying to find some under root of negative values. In that case, when it is not possible to get a number, in that cases, you will see these NaN values coming up. So we can check for these NaN values and work on them, maybe replace it or delete those values. So let's create a data frame first. Student ID, marks in English and marks in math. These are the default indexes which it is printing. Now check where are the NaN values. So you can do this with the help of isNA function. So wherever it is true, it will give you a Boolean true false. So if it is NaN, it gives true. If it is false, it gives you the false values. If you want to know if any column contains NaN values or not, that can be done using any. So it tells you which columns contain the null values. If there's a single NaN value, it will give you true. See, student ID, all were false. All the student IDs were available. So student IDs will give you true. And even if there is a single NaN in marks English, marks math, it will give you true for that. Dot sum can be used to now check how many NaN values are there in a column. So df.isNA will check how many. So df.isNA prepares a data frame like this. And if you're using a dot sum on top of it, then it will find. It will count how many null values are there. Wherever true is there, actually, basically, it looks for the true values and count how many true values are there. Inside the any, you can decide on the axis also. Column wise, you can do, row wise, you can do. That can be decided using axis 0 or axis 1. So here we were talking about columns which contains null. Similarly, rows which contains null, you revert it. Give axis is equal to 1, it will tell you which rows contains null. Okay, these are different ways how you can know where null values are. Now, you are interested in replacing these values wherever NaN is there. So we need to know the index wherever null values are there. Row index where null values are, that can be done using dot index. Get the index wherever null values are there. This much we have done. See, the output of this is, you can see here. We have NaN values in these 3 rows. Dot index will give you 1 to 5. These are the 3 indexes which have null values at these 3 indexes, and toList is just used to convert it to a list so that it can be presented to you. Till here, is it okay? Axis is equal to 0 and 1 can decide whether you want to go row wise or column wise. See, in case you want to know the meaning, you can click on this, click on Shift tab. It will give you the summary. Here also you can read how it works and all, any of the function. Axis is equal to 1 is deciding whether we are going row wise or column wise. Till here, is it okay? What we have done till here? Goal, have you understood? We have identified the indexes of the rows anywhere in which NaN is there, null values are there. Index we have got. Now we will work out on those indexes. So these indexes maybe you can delete. Drop NA is used to drop those values. We'll see how to delete those. Or we'll see how to replace those values. Now replacing, or how do we handle multiple NaN values? So this is my data frame. We prepared this DF data frame here. Data frame dot drop NA only you have to use to drop all the values where NA is there. So it will remove row number 1, 2, and 5. These are different variations you can check out yourself. Same things we are doing on different data set now. Replace, first of all, replace those question marks were also there. So replace it with NaN first of all. Then you can go for dropping the NA values. It will drop all the rows wherever NaN is there. Deciding on the axis row wise or column wise you want to do it. In place is used to replace the values actually in the data set, or otherwise what happens if you do in place false, or if you do not supply it by default it is false. So it will drop it for now, but in the original table it will not be dropped. So for dropping it in actually in place, you have to make it true. Threshold here is 13. Yes, that's a data loss. You are right. When we drop rows with NaN values, definitely the values which it holds for the other columns also you are dropping. So complete rows it will drop. So there is a data loss. Threshold is for deciding on the percentage of number of rows. In this data set, you can see we have 14 rows. So threshold is 13 means at least 13 non-NA values should be there in my column. If 13 NA values are there, then there's no need to drop. So that means, or reverse, if I say if I have more than one NaN value in my column, then only delete that particular row. So this threshold allows you to decide on how many NaN values you want to remove that row. Let's say, see, if I go to the data, if I talk about this, for row number 1, I have only one NaN value. For row number 2, I have only one. For row number 5, I have two NaN values. So this threshold allows you to decide that do not delete the rows which have only single NaN anywhere. Beyond that, if it is there, if it has more than one NaN row, then only delete it. Okay, so this threshold depends on your data because it will take up values from your rows and columns. Based on this 14, because my data has 14 rows, that is why we have given here 13 to ensure that data with a single NaN value does not get deleted. If there's more than one NaN value, then only delete that row. Restaurant details also in one go replace all these values, question mark or space or NA. If it is there, all these means null only for us. So replace all of them with NaN. Okay, in the restaurant details table, and then go for dropping the null values. You can check the shape again. It will drop all the rows which contained question mark anywhere. This time our threshold is changed 11. You can keep changing this threshold and see the difference. So now it means more than 2. We are looking for more than 2 NaN. Then only it will get deleted, otherwise not. See, this data had the first row has single NaN values. It didn't get deleted. NaN values, it didn't get deleted. Again, if you are seeing this inconsistency in state, that means original data was picked here again. You can go from the starting, clean it first, modify all these SLP values. Again, restaurant details table, just to show you how drop columns with more than 40% missing values. If for more than 40% there are missing values, then only delete it. So we had, I think 110 rows were there. So out of the 110 rows, 60% threshold is 60%. So if 60% of the 110 rows have some data, they are not null, retain them. And how do we decide on rows and columns? From access. This is to check what are the different columns. So dot columns dot values will display the columns, and you can see how the other columns have been dropped if some columns are dropped. Drop the columns which contain 40% missing values. More than 40% missing values, then delete those columns. Now let's see how we can replace those. Deleting is fine. We have seen how to delete subjective deletion, percentage wise deletion, delete on. We have seen how we can get rid of null values or how we can replace that value also we have learned. Now let's see how to replace those values with mean, median, or some constant value. For that replacing is called imputing data. So impute means replacing that value with something else, some meaningful value. So for that, we will make use of simple imputer. So you have to import this class simple imputer from sklearn.impute. Install this package if it is not already installed, scikit-learn as you did earlier, then we'll go for imputer. Now here, restaurant details, let me check if, okay, I need to I'm simply loading this file again, restaurant details. Then doing this step, cleaning it, transforming my state values. Restaurant details, country. Yes, we'll see what is impute. Let me import my data. Now, let's try deleting and impute data. Okay. Simple imputer. Now let's check what's there in the country column. So in the country column, if you have any null values, let's get the indexes of the null values. Okay, currently it doesn't contain any null. So let me modify my data. You have to go to restaurant details file, which you have created. So I'm currently going to my restaurant details. Yeah, got it. Restaurant details file. And in the restaurant details file, I'll introduce some null values there. Now, can you see my screen? Can you see my screen now? Notebook? Okay. Actually, you have to come from, I didn't execute all these steps. You have to replace all these values. There was no NaN. So your my is any function was not able to retrieve any value. Because there was no NaN value, there were question marks, space, and NA. So you have to replace all that with np.nan first. I did that. And then if you check, if you execute this, find the index of all the rows in which NaN is there now. So I have got these many rows. So all these indexes have NaN values. Now let's check. Let me replace it. See, all these have the country values NaN. Now let's see how to fill it with a constant value. So we can make use of simple imputer to do that. In my array which you have created, I am not doing it in the original array. So we are doing it in a separate data frame. Create a separate data frame for it. Country array. This is a new variable, new data frame we are creating for this. Now in this new data frame, we will transform it. So before that, you have to create an object of simple imputer. You have to provide the strategy that we are going for a constant filling. So this strategy can be mean, median, most frequent. I'll show you it. This is the strategy here. See, for example, mean. Your strategy can be mean of all the columns which are there in the country, or median, or you can go for most frequent value or a constant value. So this is my categorical column. Country is a categorical column for qualitative data. So here I have to go for a constant value. Mean, median, mode cannot be found. So I'm going for a constant strategy here, and you have to supply the fill value here. I want to replace all these values, all these NANs with Mexico. Okay. With a constant value Mexico. So till now I have just created an object of simple imputer. Now using this object, you have to transform your temporary array. That's it. Shape we have to decide again because this takes the data frame. So I have to reshape it to some data frame which matches my imputers. There you go. So all everywhere it is replaced with Mexico now because yes, reshape. See what we'll do is I'll show you what the reshape is doing. Reshape is for changing the shape of your data frame. Okay, we'll do it this way. Control C, down. First of all, let us check this. This is my shape currently. If you just display country array, now reshape it and see the shape. Okay, this is what we are doing. So this you have to reshape it and then give it to imputer. But again, we have to reshape it back to the original shape. So for that, I have again reshaped it. Now let's check for the indexes. We found that these indexes were having NaN. Same indexes we'll check what they contain now. Where is it? Here we go. Again, check what these indexes contain. They have been replaced with a constant value Mexico. Instead of going it the loop way as we did earlier, finding wherever it is question mark or NaN, replace it with Mexico, we have used simple imputer to do that. And now changing it with the mode value, median value, most frequently occurring value. Mode value is the most frequently occurring value. So here we have to let's check on this first. This time we are working on consumer survey. We are finding how many wherever it is NaN values. These are the indexes I'm getting. On these indexes in the consumer survey table, my transport column has null values. Let's print them. Check for it. You see, transport column contains null at all these places, all these indexes. Take a value count of it to check the transport type. There are 82 vehicles public, 35 car owner, and 14 on foot. Here, strategy in place of constant, you have to use most frequent, rest of the code is same. We are using simple imputer to do this and put it back to the original array. This last reshape was not there. I added this. You check if you need it. I'll share this with you in the chat window. In the original code which you'll download, this dot reshape will not find. So the most frequently occurring value is public here. So it automatically picks up the most frequent value, and simple imputer replaces all your null values with the public, with the value public. Let us check. Imputing with the mean value would be same, just that function we have to change on a different data set. It has been shown here. You can take it up. Checking the indexes, then okay, check the mean, what is the mean value, and use mean function here. Strategy should be mean. That's it. All right, now when you replace it with mean, this time we are actually adding one more column to our data set. Instead of replacing the original values, just add one more column to the data set. So these were the values which were having NaN in place of average dine-in per month, but then it got replaced with the mean value. You can see here. Correspondingly, we have printed their state as well here. Now let's find average dine-in per month, mean of the average dine-in per month state-wise if you find. So this is the data. So you can use group by on state, group by all the data on state, and find the mean of average dine-in per month. So this is giving us like this. If you do not clean your data, if you clean your data, definitely it will give you the original values on the clean data. So currently I cleaned the data. So at present it is showing me like this. You can replace it with the median also. Strategy, you have to choose median. See, I'm not going through all this because it's just a repetition. You have to try it all yourself. On different data sets, it is the same thing is shown. How to impute your data with mean, median, most frequently occurring value, and then constant value. Now let's see how to merge data or how to subset a data frame. See, it totally depends on your choice whether you want to, which statistic you want to use. We do not have a fixed rule for it when to go for to go for a meeting. It totally depends on your logic. NONE, none is explicitly in at some places in the cells you will find this. That is actually a string none. Maybe the person doesn't know, so we write now. If we ask a question, we are not in a mood of answering, we write NONE, no. That type. So NONE is a string, it has been used as a string here. NA and NAN is same. That is not a number which stands for NP. Okay, before starting on merging, a question to all of you. You have studied SQL? You know what are tables in SQL? How do you join tables in SQL? You know how to join tables in SQL? What it means? Inner join, outer join, cross join. Okay, people know. I just got one no, otherwise, yes, people know. Okay. If you do not, a little bit is okay. Because that is required here. Merging two data frame, we need to understand what is that join. It becomes very easy if you are familiar with those concepts of database joins here. Let's say we have two different tables. We have restaurant details, you remember, where all the details of the restaurant was there. In my cuisine table, only two columns were there, if you remember. Corresponding to my restaurant place ID, it was talking about what cuisine it offers. Remember, details table didn't have that column cuisine type, whereas my cuisine table had that column cuisine type. So there's a mapping. Now, what if you want to know all the restaurant details along with the cuisine which they offer? How will you get that? I have to merge the two data frames, two files. I need to get data from both the files. It's a case of inner join, like how we do inner join in my tables. You have two tables, restaurant details, restaurant cuisine. You have one column which is common between the two, that is place ID. For every place ID, details are there here in this table. Only the cuisine type is there in this table. So for every place ID, there will be a match. Wherever it gets a match, all those at those places, it will match that data. So initially you can see my restaurant details have these columns. After doing some changes, modifications, initially it was only average dine-in per month, but then we added one more column with mean imputed data. We added one more column with median imputed data. Okay, when you will go from top, you will end up getting this kind. Then cuisine had only place ID and R cuisine. Now, what if corresponding to all these details, here I want to add one more column R cuisine, which talks about their cuisine as well. So we can make use of pandas merge function, pd.merge. Two tables they have to supply here, which have to be merged, and the type of join which you want to do also has to be supplied. Column on which that join will happen, we have to supply. That's all we have to do in the argument section. We'll do all this. So either you say A dot merge B, that can also be done, or you can go for PD dot merge two tables here. This is table number A, table number B. Now table B, we have to specify the index of this table so that the merge can happen. So in my second table, this place ID, we have defined as the, to be as index, to be used as index. And from the left table, place ID has to be used for merging. Okay. Right index true means use the index from the right side table, that is place ID. And the type of join which I want to do is inner join. So here, if you go, you can check its details. Left. So first of all, the attribute we give is left table, right table or data frame. How you want to merge it, inner, outer, that can be specified here. So we have outer join, Inner join, cross join. If you do cross join, it gives you m cross n rows. So if you have m rows in the left table, n rows in the right table, cross join maps all the rows in the first table with all the rows in the second table and gives you m cross n rows. That is cross join. Cross join can give you meaningless data also. So most frequently used join is the inner join only, which makes some sense. Corresponding to a place ID 1, it has to be mapped with the place ID 1 in the cuisine table. No, I have not shared another screen. I just clicked on merge. Is that window not visible? Details. You point to the function and then press shift tab. It is visible. You can check the functionality. Okay. Thank you. Thank you. It's good if it is visible. So this is all what we are doing. So now you can see again, you go and print the values corresponding to this place ID. It will find the place ID in this table, search for the cuisine and then give you the cuisine here. This is merging. Same as in your SQL. Inner join. Number of rows you can see in the table A, restaurant details table, you had 130 rows. In cuisine table, you had 916 rows. And in the final table, which we have prepared after joining, we had only 112 values in the place ID column. Another example for merging restaurant details cuisine now with restaurant parking. So you have got cuisine info. You are also interested in knowing parking availability. So merge it again. Same thing we are doing to add the parking lot details as well. Second example. Subsetting the data, how do you get a subset of the data? We have already seen using LOC, how you can fetch data. So before comma, number of rows, it means there's only a column, it means this is for you to answer yes, all rows. If you have only column, it means all the rows. And after comma, I have these columns, it means only these columns. So I'm filtering data. I'm creating a subset of the data frame which I created above here. From this, I'm interested in knowing only these columns, all the rows, only these columns. And because this file will have 130, 110 rows, why to print all that? We have used this dot head here to print only the first 5. So only these columns are coming, first 5, yes. By default, first 5. Place ID, name of the place, our cuisine from the second table which we merged, parking lot from the third table which we merged later, just to show you that it has been merged. Different types of cuisines and their frequency of occurring in the table or how many times they are appearing in the table. 28 times in this table, Mexican was ordered. That's what, only one time regional cuisine was ordered in the whole data set. Similarly, parking lots, the value counts of the parking lot, how many nuns are there, how many yes, how many public, how many value. Earlier also we have used this value counts you have seen. Now let's see how to get a subset based on a condition. We are interested in knowing the details of restaurants which offer Mexican cuisine and have a public parking. Mexican cuisine and have a public parking. So in SQL, like how you frame queries from your data set, we are asking all those type of questions now to the data set here, you can use LOC to do that location. So my first rows, how do I decide what rows to pick? Only the rows where my cuisine is Mexican and the parking lot is public. For all those rows, display these columns. Or operator, I hope you know all these operators and or. So now here this time we are checking for Mexican or American cuisine. So put a or operator in between. Locate all such rows. Mexican cuisine, American cuisine. Okay. So how to get a subset of data based on the conditions, how to filter records or columns from your data set. Now let's see how do we put data into a certain order. Before ordering, you can see these are the columns and some data for these columns. For ordering, we can use sort underscore values function. Instead of LOC now this time, we have to use sort values. Sorting on which column you have to do, that has to be specified. So all the data in the consumer survey table, sort all the rows on the column FRVPM. Sort all these rows and then display only these columns, first 10 values of these columns. So you will have a sorted data, which is sorted on FRVPM, restaurant visits per month. So here you can see 2, then 3. This last column, FRVPM. So sort the values and in the by clause, you can specify. Only one column, single column we have used for ordering. More than one column if you want to use. That also we'll see. Before that, okay, more than one column if you have ordering, then you can specify here, comma, this, specify the column name here. Now, if you want to do it in descending order, add one more attribute here. Along with the by, make ascending as false. So this will be in descending order. If you want to add columns, now let's see. See, I have not specified anything. Just you have to, how do we invoke a column? If this column already exists, then whatever you are doing on the right hand side will be done on that same column. If this column doesn't exist, then the highlighted portion will create a column. Add a column parking availability in this data set, in this data frame, and store the results, what you are doing here. So here we are checking whether parking lot is none or not. If parking lot is not equal to none, then parking availability becomes true. Otherwise, it becomes false. So we are adding one extra column here, parking availability, true, false. So you can check adding one more column here. Let's count on the parking availability values, true, false. You can use value count. Another feature which can be used for exploring is melting a data set or reforming it, casting it back again to the same shape. So we can use pd.melt, pandas melt function to do this. So initially, if you print your user rating file, it will be like this. For every place, user has given some rating for food and some rating for service. If you want to change its format, I'll show you the output first so that you understand. See, if you want to display it like this, rather than having separate column for the ratings, food rating, service rating, What if I want it this way? So I'll have in the third column, you can see food/service. So this user has given for this place ID, food rating is this. If he has given service rating, that also would have come here. So same user has given for same place ID, service rating is this. Maybe. Ideally speaking, this looks good, but in case you want your data to be displayed like this, can be done using melt function. Now in melt function, you have to supply your data frame, the IDs which have to be used as it is, then the values which have to be used for melting. So I need food rating and service rating will be melted. New variable name which I want to use, that is food/service, has to go as variable name. And the value has to go last. The name of the column has to be decided. You go through the syntax, you will understand what is happening. Casting it back from this, if you want to make it, you want to represent it this way, separate columns, you can use cast function to do that. So melted data, again, if you want to make it back to the original shape, then use cast. So here for casting, we have used pivot table. So we have two functions, cross tab and pivot table, to find the frequency of occurrence of any category or any quantitative attribute also. If you want to find, that can be done using pivot table or the cross tab function. So here we are using pivot table on the melted data set, provide the index, columns which have to be used in cast, and the values. So it will find the frequency. We are doing it on the melted data set. If you do it on the original data set, so instead of this count, we can supply the aggregation function also in the pivot table. See here, take one more attribute, aggregate function mean. So it will find the mean rating in that particular place. This pivot table is used for presenting. Look at the output, then you will understand what is happening here. So for this place, food rating is 1, service rating is 0.25. It is giving you mean food rating for this place by any of the user. This is mean service rating for this place by any user. Exploring and summarizing. Summary, okay, how to visualize your data, you already know. We'll just run through it once again. You remember this box plot? We have learned how to create box plot, hist plot, and all those plots. 5-number summary also, I think we discussed in the last class. Here again, how to print 5-number summary. Just pick up that column and say describe. So describe function is used to print this 5-number summary. 5 numbers are minimum value, which is there. So here it is telling me in FRVPM column, the minimum value is 2. That means minimum 2 times a place was visited, frequency of restaurant visits per month. So minimum value is 2. Maximum a person has visited is 60 times. This 25 percentile tells us 5 people. So 25% of the data has value 5. 5 or below. 50% means median value. So 50% of the people visit the restaurant 8 or less number of times. 75% of the people visit the restaurant 12 or less number of times. This is restaurant visits per month. RVPM is restaurant visits per month. Plotting, you can use any of the technique what you have learned earlier, or here they have shown you using Seaborn. The box plot is giving us this. So I hope now you know how to read this. Upper whiskers, lower whiskers, and outliers. So box plot is used for identifying which data points are lying outside. So maybe you identify the outliers and maybe you're interested in deleting them. Find the outliers. Let's see how to check for the outliers here. So box plotting, you know how to do that. Now, how this upper whiskers and lower whiskers are decided, that range if you want to know. See, maximum if you print describe, you use describe function, maximum you will get a 60 here for FRVPM. But my upper whisker is decided at somewhere here, 22, 23 in the mid of that. My lower whisker is decided at somewhere 1 or 2 approximately. So are these original values? Let's check. Let's go to the describe and check. My lower whisker is this minimum is 2. So maybe approximately it is correct. My lower whisker is pointing to 2 only. But is my upper whisker pointing at 16? No. My upper whisker is pointing at some value which is 22 or 23. It is, you remember what? Minimum of two things. Either the maximum value or it depends on interquartile range. How do we find that interquartile range? What is that interquartile range? Interquartile range is the one which lies between 25th percentile and 75th percentile. Yes, the number. So maybe let's say 75th from 5 number summary. Q3 minus Q1, correct. So that means my interquartile range here will become 12 minus 5. 12 minus 5 will be my interquartile range. My upper whisker will be 12. So what is 12 minus 5? 7. My upper whisker will be 12 plus 7, that is 22. My lower whisker will be 5. 5 minus 7. 5 minus 7 gives you? 5 minus 7 gives you minus 2. It is coming in minus. So minimum of these has to be taken. Minimum of, let me write if you have forgotten. So see, we have got two values. Either 12 plus 7. My upper whisker will be either 12 plus 7, that is, oh, sorry, not 7, 1.5 times of interquartile range. 1.5 times of interquartile range. 12 plus 1.5 times of interquartile range. So either this value or 60 will be chosen as the upper whisker. Whichever is minimum will be chosen as the upper whisker. In our case, maybe this is coming somewhere 22 point something. That is why upper whisker is chosen as this, not the maximum value. But when it comes to the lower value, then either 2 or my 5 minus 1.5 times of my interquartile range, that is 7. It will give you a negative value. This gives us a negative value. Yeah, that's why the minimum has been chosen here in this case. 2 has been chosen, not the negative values. If let's say it would have come somewhere 1, let's assume your after subtracting it would have come 1. In that case, 1 would have been chosen as the lower whisker, not 2. So whatever data points come beyond this upper whiskers and lower whiskers become your extreme values, which can be ignored, which actually doesn't add some value, or they hamper a lot. I think we have talked about this. If I put this 60, find a mean median mode, how much it will affect? Just this one value will affect the whole calculations. So we can ignore these exceptions. The whole thing, they have written it here and derived it here. Upper limit, lower limit. Plotting a histogram, you already know now how to plot. Divide data into a bin. It plots a univariate plot. Frequency. Box plot, histogram. Yeah, this cross tab also can be used to analyze. the frequency of the categories which lie in a column. Let's say you want to know gender values. Different categories of gender values will be male, female. So how many people in my data set are male, how many are female? Either one thing is you do it all by yourself, find all the categories, group your data, use group by, and then use value counts. That is one way. Or we have this direct functionality, cross tab can be used for finding the frequency of the qualitative attribute across all categories. So this we are using pd.cross tab on gender column. It will identify all the possible categories and give you the frequencies, give you the count of that. Income, see, we are not specifying anything else. Automatically, it will identify what are the different categories and give you the frequency of it. Conditional, if you want to do, let's say, how many customers visit the restaurant more than 10 times in a month, if you want to know. So give your condition here. Based on the condition, it will give you true false. So it says 44 people visit the restaurant more than 10 times a month. We are using cross tab. Region wise count. Comparing multiple histograms. This is another example of pivot table. I'm just having a look if something which I need to tell is left there. Okay, yeah, one more important thing. See, rest all you can go through yourself because data visualization you have you already know now. You will be able to understand what is happening, how to compare different values. This paradox we'll see. See, at times what happens, you have, let's assume this data, day one, this is ticket number 1, Bob, it was pending, T2, John pending. So this is telling you about the ticket number, on which day it was assigned to which person, and whether it was resolved or it is still pending, status of the ticket. So we are creating this data frame. This is my data. Now let's visualize it. We are look at this visualization using cross tab. For all the categories in assignee, there are only 2 people, Bob and John. Now, how many tickets are pending for them? How many are resolved for them? We have found a frequency. So it says total how many tickets Bob has resolved? 2. Total how many tickets are pending for Bob is 3. 3 tickets are pending for Bob. Similarly for John, 2 are pending, and this is a total which we are getting. Now let's represent it in some other way. Day wise, let us split it. How many they have resolved day wise? How many are pending for them day wise? If we do, so we have to supply 2 things here, day wise and then status wise. Let us check how many tickets they have resolved. So here you can see they have resolved, Bob has resolved 1 ticket, whereas the pending is 3 for him. So we have this data. Now see, when you represent it in some other way, now let's reverse it and see day 1, day 2. So Simpson's paradox say that sometimes when you represent your data, maybe you are able to see a pattern which you might not be able to see when you group it in some other way. So patterns might dissolve, might disappear.